Hi everyone, welcome to YourPedia Education. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. In this video, I am going to discuss some important topics and questions which can be asked in a BARC interview from the subject Control Systems. Control Systems is one of the very good subject and important subject for the branches like electrical and electronics and instrumentation. And control systems is not going to be a single subject. It is the combination of the subjects like networks, sometimes operation amplifiers, analog electronics also will get involved, not in deep but application orientation, those are going to be involved. So in this video I'm going to discuss some problem questions and concepts for BARC from control systems. So in BARC they will start with one of the very simple question, then they keep digging on that question further, right? So the very simple question they start with, the question is yes, what is time constant and what is the significance of time constant? What is time constant? Yes, and what is the significance of time constant? Significance of time constant. What is the purpose of this finding time constant, right? So very simple definition, all of you know what is time constant. That is, it is the time taken by the step response to reach 63.2% of its final value. Now here some possible questions in this answer are, why you are taking step response? The definition of time constant is, it is a time taken by the step response to reach 63.2% of its final value or steady state value. Then immediately the question that can be asked is, why only step response? Why not ramp response or parabolic response? Why step response means a step response is a bounded value. Yes, for a stable system, the final output or the step response of a system is a bounded value. Suppose if I take this system, I'm giving here 10 into u of t, means 10 into u of t is magnitude is 10, and that is the step input. This is a switch which is closed at t is equal to 0. This is R, this is C. Now what is the voltage across capacitor? What is the voltage across capacitor? Yes, voltage across capacitor Vc of t is equal to 10 into 1 minus e power minus t by tau, where tau is nothing but time constant, that is R equivalent into C equivalent. But in this circuit it is RC only, and the units of time constant are seconds. If you see at steady state or final value, if you see the steady state value or final value of voltage across capacitor is going to be 10. Steady state means the time t tends to infinity. If you put t tends to infinity, e power minus infinity is 0, 1 minus 0 is 1, 1 into 10 is 10, right? So my point here is, it is the time taken to reach 63.2%. Why you are taking up to 63.2%? We are not taking it. See, if you take voltage across capacitor Vc of t is equal to 10 into 1 minus e power minus t by tau. Now if you take the table t and Vc of t table, when my time, actual time is 1 times of the time constant. Tau is a fixed value. Once if you take the R and C values as fixed values, then tau is going to be fixed value, right? So when t is equal to tau, we are going to get 6.32 volts. 6 point means this will be 0.368 something. 1 minus 0.368 will be 0.632 into 10 will be 6.32. So this is nothing but 63.2% of Vc of infinity. Tell me, what is the voltage across capacitor at infinity? That is equal to 10. If you put t is equal to infinity, e power minus infinity is 0, 1 minus 0 is 1, 1 into 10 is 10, right? So this way we have to understand, means when your time is exactly equal to one time constant, the output is going to be 63.2% of its final value. And so why we are talking about step input only, step response only? Why not ramp and parabolic responses? Step is a bounded value, step response is a bounded value. Yes, if I draw its graph, with respect to time, this is t, and this is the input, step input what we are giving or what we given. then the output will start from 0 and it rises like this. Finally it is going to settle at yes, this is the output, and this is equal to 10. But if we give, if input is equal to some 10t into u of t, your input itself is unbounded because its magnitude is going towards infinity. Its magnitude is going towards infinity like this. So you can't say what is its final value. What is the final value of ramp input, ramp signal? We don't know. It is going to be in fact infinite. So it is not possible to get bounded output at the final stage. That is as t tends to infinity. That's why we use step input only. Right now, immediately see, we taken some example of RC circuit. This is RC circuit. Yes. Now the switch is closed at t is equal to 0, and that fellow says that this circuit is under operation. This is 10 into u of t is the input, and suppose this is R is 10 ohm, C is 1 microfarad, and time constant tau is equal to R into C. That is equal to how much it is? 10 into 1 microfarad, 1 micro, that is 10 microseconds. Now here one possible question is, sir, you are saying R into C. R is in ohms, C is in farads. So ohms into farads, will you get seconds? Yes, we have to prove. They'll ask you, do you really get this ohms into farads as seconds? Yes, we get. I'll prove here. See, R into C, R is in ohms, this is C, that is in farads. So what I do is, I is equal to C dV by dt, the typical relationship of a capacitor, right? This is in amperes, and this is C in farads, yes. And dV is volt, dt is seconds. Now farads is equal to ampere second by volt. Put there, farads is what? Ampere by volt into second. Volt by ampere, see, ohm is ohm, volt by ampere is a ohm, but ampere by volt is 1 by ohm. 1 by ohm into seconds, ohm gone. So finally you got it as seconds. Ohms into farads is seconds. That is one possibility of asking question. Another possibility is, brother, I have this RC network, I want to reduce its time constant. What is your proposal? I want to reduce its time constant without disturbing the circuit. See, you don't want to open. See, some people will say, sir, if you want to reduce the time constant, reduce the resistance or reduce the capacitance. But how to reduce resistance? It's not variable resistance. My present time constant is 10 microseconds, but I want my time constant as 5 microseconds. Then what to do? The possibilities are, this is the possibility. See, this is not variable resistance, this is not variable capacitance. Some people will say, sir, let's put variable resistance and reduce it. That anyone can think of. That's not a big deal. But if I want, see, I write here, if tau is equal to 5 microseconds is required, then come on, yes, this is the circuit, this is 10 into u of t, yes, this is input, we are not disturbing the input at all, and this is the resistance, this is the capacitance. What's your idea? This is 10 ohm, this is 1 microfarad. Now without disturbing the existing circuit, in this current is flowing now, the switch is closed, we are not allowed to open the switch and change the resistance value. What to do is to connect one resistance in parallel, 10 ohm, 10 in parallel with the 10 will be 5 ohms, this is 1 microfarad, then tau is equal to 5 into 1 micro, that is equal to 5 microseconds. So this is an innovative thought. So this kind of questions will be asked. If you want to reduce the time constant without disturbing the existing circuit, you connect some resistance in parallel with the existing resistance. You have to choose the new resistance to connect in parallel with the existing resistance in such a way that is going to reduce the overall resistance and overall time constant is going to reduce, right? Now, sir, I want to increase the time constant. So now tau is equal to R equivalent into C equivalent. If I want to increase it, you have two methods here, two possibilities theoretically. One is an increase either resistance or capacitance. But without disturbing the circuit, if you want to do it, you can't increase resistance. You connect in parallel, then the resistance is not going to be increased. Suppose if this is 10 ohm, any resistance you connect in parallel to this 10 ohms, that will be either equal to 10 or less than 10, but never it is going to be more than 10. Yes, then what is the idea? Now, now that is very simple. This is not micro, please. This is U of t. Just a minute. This is U of t. Yes, 10 into U of t. Observe here. This is capacitance. This is 1 microfarad. You can suppose I want tau to be 20 microseconds. What to do, sir? Resistance is 10 ohms. It can't be changed. But C equivalent can be changed. You connect one more capacitance of 1 microfarad in parallel, then it is going to be C equivalent is going to be 2 microfarad. You know that capacitance in parallel will be directly added, right? So this way, from one question after another, they will link with control systems, they will link with network analysis, sometimes analog electronics, right? So this way, they are going to ask you the questions. What is the significance of time constant? See, time constant is going to depend on particularly system parameters. It's not going to depend upon input and output. So this is the question possible. The time constant, the input to a system is doubled, then what about time constant? Time constant is independent of input and output. It is going to depend upon system parameters like R, L and C. Now, all the time response characteristics like rise time, delay time, settling time, peak time, okay, all these things are going to depend upon time constant and time, and I can say system parameters, but not input and output, right? So, if you know the time constant, you will be able to find its settling time. Right, settling time is one of the very important. Then some new questions can be asked on settling time. They will use some circuits, some systems. They will ask you in the interview to find the settling time of this one. So time constant is very important, and depending on time constant, we can get the bandwidth of the circuit also. Now, if you say this one, then they will ask you what is bandwidth and how to find it. Like that. See, in BARC interview, if you keep on answering and your thought is going in right direction, they keep on asking. Right? So if they get satisfied, then they will move from one subject to another subject. And one important thing for the students who are preparing for BARC, that is, don't think that you are preparing only control systems. Yeah, only control systems is not going to serve the purpose. Only networks, it will not serve the purpose, right? So, suppose if you are preparing the control systems, you must have the knowledge of network analysis and analog electronics, especially operational amplifiers, at least. Okay, because all our subjects are linked with each other. They will give you one third order system. Some third order system. Suppose an example, they will give you like this. R, L, and C, and one more L like this. They will give you. This is R. Let's take some values, some random values. These are not the fixed values. This is 1 ohm, this is 1 Henry, this is 1 microfarad, and this is 1 Henry. Now, what is the time constant of this system? How to find the time constant of the system? They won't expect to correct the exact value of time constant, but they will see how you are approaching to find the time constant of that system, right? Yes or no? So this way questions will be asked. Stay tuned to this YourPedia education channel. So you are going to find a lot of this kind of videos for BARC preparation. BARC preparation from the subjects control systems, networks, and for electrical students, I can say power system, electrical measurements. On these subjects, I will be making a lot of videos to give you inputs. Right? Thank you.